Well, hello again. Today we are going to talk about the role of the hypothalamus and the pituitary and the hormone thyroxine and how thyroxine regulates metabolism. So here we have a lovely picture of the brain. And in the brain, there's a part of the brain called the hypothalamus. Okay? And it is the hypothalamus that links the nervous system to the endocrine system. Okay? So any signals from the nervous system that need to talk to the endocrine system go through the hypothalamus. Okay? And the hypothalamus talks, in quotation marks, to the endocrine system using the pituitary, or the pituitary gland. And the pituitary gland is located right below the hypothalamus. And there are two parts of the pituitary gland, the anterior pituitary and the posterior pituitary. Do you need to know them? No, but there are two parts. The anterior pituitary and the posterior pituitary, and the pituitary secretes several hormones. We are going to look at one example, but sort of the same principles that when we look at thyroxine is the example that we're looking at apply to all the hormones that the pituitary secretes. So again, this is kind of what we just said in text. So the hypothalamus is the master nerve control center, and it receives lots of information from nerves about internal conditions in the body. The one that we're going to be talking about in this video is temperature, but it also plays a role in pH sensing. There's even some evidence that it plays a role in sugar sensing levels. And the hypothalamus, to talk to the pituitary gland, releases hormones. And these hormones regulate the release of other hormones from the pituitary. Okay? The pituitary is known as the master gland of the endocrine system, and it secretes what is known as tropic hormones, which regulate other glands in the body. So it's almost like a three-part system. The hypothalamus secretes hormones, which then talk to the pituitary, and the pituitary talks to other glands in the endocrine system. But again, the key thing to understand here is that the hypothalamus, hi Kaiser, Kaiser jumps up on the computer. As I got distracted by Kaiser, I forgot what I was saying. I'll have to restate what I was saying. So the key point is that the hypothalamus, okay, which receives lots of information from nerves in the body, links the nervous system to the endocrine system through the pituitary gland. So before we go talk about the relationship between the hypothalamus and the pituitary and the thyroid gland, let's talk about what hormone the thyroid gland makes. So the thyroid is located in your neck. Okay? And it makes a hormone and stores a hormone known as thyroxine. Okay? And the hormone does many things. You can see all the things it regulates here. The main one that we're going to talk about is how it regulates metabolism. That's the main thing it regulates, or how fast the chemical reactions of your body occur. So basically how fast respiration and digestion occur in your body. And that's regulated by thyroxine, which is produced by the thyroid gland, which is located in your neck. So, if you remember when we were talking about thermoregulation, one of the reasons why you would want to increase your metabolic rate is if you were cold, okay? And it's the job of the hypothalamus. The hypothalamus is sort of like the thermostat of your body to sense when your body is cold, okay? And remember, when your body is cold, endotherms like us want to raise our metabolic rate so that we can produce heat to warm our body and maintain our body temperature. Now, so when the hypothalamus, okay, senses that your body is cold, it releases a hormone known as TSH releasing hormone. Okay? And, which is abbreviated TRH, believe it or not. Usually we use the abbreviations and not these long names. TRH talks to the pituitary, specifically the anterior pituitary, but you need to know that. Okay, and it causes it to produce thyroid-stimulating hormone, also known as TSH. Then TSH travels through the bloodstream to your neck, okay, where it tells the thyroid to produce thyroxine. Okay? And then thyroxine, okay, will increase your metabolic rate, which will increase your heat production, and therefore rewarm your body up. Now, if you look at this image here, you'll see these red arrows. Okay, and these red arrows are very important. Okay? This is sort of another example of negative feedback. Okay, and these red arrows or negative feedback prevent too much thyroxine from being produced. Because, okay, when either too much thyroxine, okay, or too much TSH is produced when it gets to a certain level in the blood, it feeds back and inhibits the hypothalamus from producing any more TRH, which then inhibits the anterior pituitary from producing any TSH, which then the thyroid doesn't produce any thyroxine. Okay, this negative feedback loop is important because it prevents too much thyroxine from being produced, right? Because if you produce too much thyroxine, then your metabolic rate is going to be really, really, really high. You're going to produce a lot of heat, and you're also not going to be able to store any food as for just for food storage. You're just going to be doing your chemical reactions really, really, really fast. So this negative feedback loop where thyroxine feeds back and inhibits the hypothalamus from producing any more TRH prevents overproduction of thyroxine, and therefore it also prevents a too great increase of metabolic rate. Just to summarize, I want to go over the role of negative feedback and the thyroid pathway one more time. And instead of, if this was in class, I'd write it on the board. But instead I had to type it because I'm home and I don't have a smartboard at home. So, first thing that happens is that when thyroxine levels get, and once again I have the wrong 2, so Tommy, you can correct me. Let me fix it for you. Where is my pen? Here. It's the wrong 2. We need an O here. Alright. So when thyroxine levels get too high, thyroxine feeds back to the hypothalamus to prevent it from producing any more TRH. Okay? Because the hypothalamus is not producing any more TRH, this stops the pituitary from producing any more TSH, and as a result, stops the pituitary from stimulating the thyroid to produce thyroxine. Okay? As a result, this prevents thyroxine from increasing the metabolic rate too much. Okay, now you may be thinking, well, what's the problem if metabolic rate is increased too much? Well, that leads to a disease known as Graves' disease, or hyperthyroidism. And that's when the body is producing too much thyroxine. Okay? Here are some of the side effects, and we'll look at some of them and why they would have this. So someone who has hyperthyroid experiences usually extreme weight loss. And that's because their metabolic rate is so fast that they're burning their food that they eat, and therefore they're not putting on any weight or storing any of the food as fat. Okay? Another symptom of hyperthyroidism is that they tend to be warm all the time. Because remember, if you're increasing your metabolic rate too high, then you're producing a lot of heat. That makes your body warm. About 3 years ago, I actually had hyperthyroidism. I was unable to, keep on any weight. And they usually first treat it with medication, and hopefully that, restores your function of your thyroid. And if that doesn't work, then they actually zap your thyroid with lasers and kill part of it almost, to reduce its ability to make thyroxine. Luckily for me, the condition was able to fix itself without having to do that, and the medication brought it back to normal. But it was they really didn't know what was wrong with me, and they did a blood test, and they noticed that my thyroid levels, or my thyroxine levels, were too high. They were able to fix it through medication. Now, there actually is the reverse of hyperthyroidism is hypothyroidism, and that's when you're not producing enough thyroxine. And actually, the symptoms of this are usually the reverse. There's usually extreme weight gain. So, because again, that means their metabolic rate is too slow, and they're not breaking down enough foods, and then that food is stored as fat. And then people with hyperthyroidism also tend to get cold, okay, because their metabolic rate is not high enough to produce heat. Alright, well that is the end of the lesson. Have a good weekend, and answer the guided questions. Goodbye.